Right, so today I'm going to do a video on the right hand console, and I'll take the side panel off and I'll show you the insides of it as well. Same as the rest of it, it's MDF construction. I've changed the plans a lot by putting, the plans don't actually come with a skin on the outside of it. I did that just for looks, obviously, and it's also good because it, if you didn't have a skin on the outside, you'd see all the wiring and cables for that. Painted it up so it looks good. These are not stickers, they're just painted. I actually put masking tape sheets in the laser and cut that myself, and then just stuck it on and spray painted it, and it came out looking pretty good. It's not perfect, there's a bit of overspray, but it looks good. And the rivet detail is just upholstery nails banged into the side of it to make it look like it's metal. It is just 3mm MDF. And I sort of based the look of it on the real A10. So on the left-hand console, it's got the canopy ladder frame marks, just like on the real aircraft. Power supplies, I'll show you that in detail, but it's just a normal computer power supply. This is just a temporary bracket. I cut it all up by hand just to work out my cables. I'll laser cut a better looking one later. So the console itself consists of the countermeasure systems panel, countermeasure signal processor, I think it's called. That was probably the most difficult panel to make in this console. Next to that you have the canopy panel. This is actually my own invention, this one. It's not like that in the real aircraft. I'm going to upgrade it later to be a bit more realistic. It actually mounts on an angle in the real one, but the angles were just a nightmare to try and cut on the laser. I'll have to 3D print something for that. Electric power panel, that one's pretty self-explanatory. It's real easy. It's just a whole bunch of switches. The caution box, they're all indicator lights. That one is run off a Fidgets 64, which is a LED card, so it's not Arduino based like most of the other panels. Oxygen regulator, easy. The only thing that was difficult was the gauge. Even that wasn't difficult. It's just a simple needle on a servo. That one's run by an Arduino. CDU, also that one is not true to the original. I've added toggle switches instead of the slide switches that are on the real one. The CDU I've also edited strays from the real aircraft because it's got a larger screen. It's, funnily enough, it's cheaper to get the 5-inch screens than it is to get a smaller 3-inch screen. I don't know why that is. And I've also edited the keys down the bottom, and I added these ones for views and radio toggles, radio menu in the game. The nav panel, again, pretty self-explanatory, just some rotary switches. That one is based off the same card that's running that. Environment panel looks really complicated, but it's not. The gauges are separate, and again, they're just single servos run by an Arduino Nano, so they're not difficult. TACAD and ILS, they are, again, stray from the real design, but they do the job. Lighting panel, this one's a bit different because the switches are all connected to the sim, but most of the dials are not. The knobs actually control, instead of the console in the simulator, they control the actual console lighting of my lighting. So they're wired up to hardware dimmers and the lighting loom. And the compass panel is right now just a placeholder. It's not actually connected to anything. Just looking good. I added a 50 cal liner just in the back of it there for map and storage, and where I can stick my projector remotes and other things. Added a cigarette lighter plug with USB so I can charge the phone when I'm in the cockpit. So the sides, this is just MDF, but I got some material that sort of looks like the interior lining on the real thing. It's supposed to be grey, but I couldn't find it in grey, so it's got a little bit of a soft touch to it. Just looks good. Flood lighting. So I eventually want to make up some actual proper Grimes flood lighting replicas with a 3D printer, either that or buy some, but they're pretty expensive online. So I'm just using these cheap little, you get them from eBay. They're sold as number plate lights for cars and motorbikes. It's just 2 LEDs in a little bracket, and because it's of the way it is, you can angle them. Just runs off 12 volt, and it's got 2 green LEDs, and I've littered them around the pit, and it does the flood lighting pretty well. Yeah, so that's a bit of a quick tour of the right hand console. Added some handles on the end for obvious reasons. Now my one also strays from the design because it's taller than the plans you buy. The plans you buy, the base of this side panel is as high as it would be, so it would just be sitting on the ground there. I added this bit on the bottom to raise the whole pit up. I did that because my seat replica is raised higher because I put it on car seat rails. I'll do another video on the seat later, but because the seat was higher, sitting in it with the cockpit lower was just felt weird. So I raised the whole cockpit. The main instrument panel, both consoles were raised up a good distance. That's just done with plywood, and I put some legs on it to raise it a bit higher because there's, I'll show you in a second, I wanted it up off the carpet because there's exhaust fans underneath there. Sorry, intake fans. So yeah, so that's about it. All the electronics cards in here are a bit of a mix and a match. So I've got the CDU is run from a Leo Bodner BBI64 card. So that's just a plug and play USB card. You plug it into any computer and it will show up in Windows as a joystick, and you can wire 64 buttons up to it. So it's a spaghetti nightmare in there because each button has a wire going to the card rather than having a simple keyboard matrix. The reason I did that and that off the BBI64 is because I want to use that in any other game, because it shows up in Windows as a generic USB controller, so I can fly other sims, other aircraft, and use the CDU for the same thing. The screen itself is a viewport, so it's not running any software. It's just a little card with a HDMI cable which goes into the back of the PC, so I can display anything on that can do it, that it can output a viewport in the game, and when you're on the computer it just shows up as a Windows desktop. Again, so I can use it for any game. Now these two here are A10 specific, so they're run off an Arduino Nano, which means they're tied to the A10. You can't use them for anything else, and it was a little bit harder to program. Obviously I needed to use that so I could get the displays exported. Now that's run off, I think I've already covered that, but it's run off a Fidget 64 LED card. I wanted to redo that off an Arduino because I could add a bit more customization to it. Right now it's only green LEDs behind everyone. My plan was to put some of those little NeoPixel LEDs in there so I can change colours, that sort of thing, with an Arduino, but I just haven't got around to that yet. This one's run off again an Arduino. I think that's an Arduino Uno in there. It's running it's a 20 segment OLED display in there, and that was actually really simple to get programmed up because somebody else had done the work for me. I just copied their sketch, and that whole panel runs off that Arduino. So again, A10 specific, I can't use that in any other aircraft. Well, I could, but I'd have to flash new code into the Arduino to do it. This one is a generic USB card. I think that is a Groovy Game Gear. The Groovy Game Gear on this one, from memory, is a bit of a medley in here. I think all the switches in most of the panels on this side are run off that Groovy Game Gear card. And like I said before, that's running the actual hardware, so that's not connected to anything. And each gauge is running off an Arduino. So there's one Arduino Uno running those 3 gauges. And the Arduino Uno runs the indicator light for that one too. So in amongst it, there's a lot of switches that are just generic USB HID devices in Windows that I can program to anything, mixed in amongst things that are Arduino Nano controlled with DCS BIOS that have to, will only work in the A10C module in DCS. Righto, so what I'll do now is I'll just take the side panel off and I'll have a look. The side panel's just held on with Phillips head screws. So I'll undo them and I'll give you a look. Alright, so all the screws are undone. You basically just prise that off. It's just MDF. I painted the inside of it green, like an aircraft interior green originally, because I planned to not have that skin on the side. And I thought it would look better if it was like a bit of an aircraft interior green. However, plans changed, so that's pretty useless now. So here it is. That's sort of what it looks like. Alright, so there's the power supply down in there. It's an Antec CP850, not a cheap power supply. It came out of my old gaming computer, 850 watts, and it can put out 22 amps on each 12 volt rail and 30 amps on the 5 volt rail. I've hacked up all the cables, a bit hard to see in there, but I hacked up all the cables, so it's obviously never going to go on a PC again. Right, so you can see that there is a USB hub in there, which is running, I'll do 1, 2, 3, 4, 5 USB cards for all the electronics, and then so there's only one USB cable coming out of the console into the cockpit. That's a powered USB hub that's getting its power from that power supply, so there's no other power plug anywhere that goes into this thing. The power supply is also powering the screen up there for the CDU. So I've broken down the power supply into this sort of power setup down here, and you can sort of, it's a bit of a mess. It's not that bad, but you can make it out. I've obviously split it into 5 volts, 12 volt rail 3, rail 4, rail 2, so I can share the load over different rails. Now down the back there you'll see another sort of power setup. So that's getting 12 volts from the main power supply into that dimmer. The dimmer is then connected to that dimmer right there for the console lighting, which breaks into that panel there, and then each one of these panels is connected to that. So when I dim the backlighting on that console knob, all the backlighting on everything in the entire cockpit will dim. That's the same setup. There's another dimmer. You can just make it up the back of there and there. There's 2 more dimmers. One for auxiliary instruments, which is backlighting all the gauges on all the panels and the main instrument panel, and the floodlighting dimmer, which is the floodlighting around the whole cockpit as well. So the only connections coming out of the whole console is that main power loop, which doesn't go to the computer, it goes to the other panels in the cockpit. I've got a HDMI cable that runs the screen, and there is 2 USB cables. The black USB cable comes from that USB hub, which essentially connects everything. And then I've got another USB cable that just runs the Fidget 64. For some reason, I can never get that working when it goes through a USB hub. It doesn't matter how good the USB hub is. And then I was troubleshooting on the forums, the Fidgets forums, and they said just try hooking it directly to a USB 2 port on your computer instead of USB 3, and I've never had an issue since. So it must be something to do with their card and USB 3 or USB hubs. It's a shame. That's another one of the reasons I want to eventually move that to an Arduino based system, so I can have one less cable going to the computer. Alright, so this plug has a pin for the floodlight, a pin for the blacklight, a pin for the auxiliary lighting, a 12 volt pin and a 5 volt pin, so it shares all the power from that one power supply around the whole cockpit. So the only mains power that goes to run the whole cockpit is that. So there's one plug just there and one main switch. I've also hidden the trigger wire for that power supply and this little switch just here, so that's sort of another main power. So if something goes crazy wrong, you just trip that and it will shut everything down. Look, I was going to rip some of the panels out, but it's a nightmare to put them back in, so I probably won't, unless I'll do videos on each panel if I need to get them out to make repairs or change anything. Another thing I thought that I'd mention is the USB hub. This is the cheapest USB hub I could find on eBay. I don't know why. It works. I have a nearly $100 quality industrial USB port that I kept getting problems with. It was weird. For some reason, USB 2, I think it's an Arduino thing too, they don't like USB 3s. USB 2 seems to work. I've never had any dropouts with this since I used this cheap $5 USB hub. Weird. So I lost 20 bucks on the $100 one, ended up selling it on eBay for 80 bucks. But yeah, now I've got 3 of those super cheap USB hubs and I've never had an issue since. Alright, you can also see that I've added just a PC 120mm fan. That's sucking air from underneath, that's why I raised it up off the ground there. And then I'm hoping that the air will sort of pass through and then be withdrawn out through that 120mm fan and out that way. The other console also has a fan in that same spot, but because it doesn't have a power supply, it's also got a exhaust fan on that side, just to get the airflow going. Look, it doesn't get very hot in here at all. I put a multimeter on it, and the whole backlighting circuit only draws like 8 amps because it's just little 3mm LEDs. It's not drawing anything crazy. And the other thing is, most of the time it's dimmed like there, just because it's super bright like that. It's too bright to even play with. So I always have it really dimmed anyway. I just also thought I'd add, so all of the switches in this thing, bar a few, are just cheap, normal eBay toggle switches. Nothing special about them. These ones, same thing, normal cheap eBay toggle switches. I just got some nice looking turned aluminium caps that a bloke on the forums makes to make them look like they're genuine locking toggles. That's one of the exceptions. That's a real aircraft knob, that one. So it's backlightable, so the knob glows on it. And that's a real cutler toggle as well. You can tell by how old and terrible it looks, but it was cheap on eBay. These ones here are actual locking toggles. They're cheap Chinese NKK ones. I say cheap, they're not that cheap. They're probably $20 each. I actually got a whole bunch of them in bulk off eBay because I don't think the seller knew exactly what he had. He was just selling switches for $1 each. I got about, heaps of them. But I stopped using them. I initially bought them for the main instrument panel, the armament HUD control panel, but because you have to pull them with so much force, it flexes a lot. It's alright on the side console like this where it's bolted down strongly, but on other panels it makes it feel less realistic in my opinion. It's just better to flick them like that. These two here are real cutler hammer toggle switches. Again, got them off eBay. I try to keep the costs down, but a lot of the time I just troll eBay, and if I see something that tickles my fancy, I buy it. 3D printed and painted up. They look really good. Those they backlight as well. I'll link to the Shapeway store where I printed them. And again, another bloke from the forums prints them. That's also a 3D printed cover to make it look a bit better. All these are 3D printed from Shapeways. I don't have a 3D printer. I just go through Shapeways. And they're from the same seller that I got those through. He's got an A10 cockpit. He's a builder as well. He's got a Shapeway store where you can 3D print all the dials and toggles you need. These ones are not true to the aircraft, but they are genuine quality ones. They're made by the same company that makes real aircraft ones. They're just a different model, and I got them for relatively cheap as well, which is why I did it. These ones are just the cheapest ones you can buy. I painted them grey and painted that line on them so they look a bit better. These ones, that's actually just a panel that I engraved myself on the bottom of the underneath the switch. I just glued it on so it looks a bit cooler. 3D printed. That one is one of these toggles. I just unscrewed the cap and screwed that 3D printed pitot heat knob on it. That's real. You can tell it's real because when I designed this panel, I made it too small. I will one day get around to re-engraving just the top of that so the defog's not blocked, but it is what it is. The light posts, 3D printed as well. They've got a single green LED underneath it. You probably can't see it, but it just shines green LED down onto that. It actually looks really cool. It's hard to pick up on camera. I backlight the gauges white, and then that little green LED lights up the the needle only, so it looks really cool. It's white backlight but a green needle. What else can I tell you about this one? Alright, so I just wanted to point out, if we look down in here, you can see that's that groovy Game Gear board mounted to the side there. That's running most every toggle except for the CDU. All the other panels are their own sort of separate unit. So the card would be connected to the back of the panel, so you could lift, not this one, but for example, you could lift it out and it would be one whole unit. Except for that one. That one fidget's mounted to the console, and all the wiring spaghetti you can see off it goes to each individual panel. You can sort of see how I've tried to make it as organised as possible, and each one's got its own little name, so I know what I have to plug into what when I pull it all apart. This little thing hanging down here is actually the control panel for the LCD, so you can like change inputs and brightness and that sort of stuff. I was originally going to incorporate that into the CDU itself, but you don't need to. Like, I never change it because it auto turns on when you turn the computer on, and once you set the settings once, you never have to set them again. I kept thinking of things that I forget to mention too. So I've used these. They're actually sort of furniture making things, so they're drilling inserts. So the side panels have a metal thread that you can fit into rather than constantly drilling straight into the plywood. Just feels a bit more professional, and it won't eventually wear out. That, however, is not the case for the panels being bolted to this. There's no fancy DZUS connectors, or DZUS I think you're supposed to say, or metal inserts holding the panels on. These are just directly bolted into the plywood. That's not an issue because these panels very rarely come out. They've basically gone in once. They get taken out once every now and then to fix something, but these have been in there for ages. They're not going to wear out because I don't constantly do them up and undo them up. Alright, so here's the right hand console sort of powered up but in the Windows environment. I just wanted to show you, so when I was talking about the dimming setup, you can see that if I dim the console, the backlighting dims and it can get pretty bright. I've also got the floodlighting here, lights up the little posts that I showed you. I've got an extra one there so it lights up my map case. Now that dimmer is also bypassed by the emergency flood switch, so if you flick that, you get full brightness on everything regardless of what that is set at. And when you flick that switch off, it turns all the backlighting off. You can see that that's showing the windows there. So the glare's pretty bad in here because I've got the lights on. I usually don't fly with the lights on. And you can see that the Arduinos, I've got them programmed so they show those dashes just to show me that they are actually working, because they're not receiving information from the sim. That's why there's nothing displayed on it. And I've got the same thing on that on the 2020 OLED in there, so I've got it saying no data link because DCS BIOS is not outputting anything at the moment. What I'll do now is I will fire up the simulator. Alright, so now that DCS is running, you can see that DCS is outputting info to the viewport for the CDU screen. It's also DCS BIOS is running, so it's outputting the information for the electronic system as well as the TACAN and ILS, and all these gauges will be working as well. So I'll start from the top. The electronic warfare panel, this is everyone's favourite, I love it too. I did mine with Arduino based completely, and all the F-16 guys love this panel too. You can see that everything works just like it would in the real aircraft, and you can set anything you want. It's pretty cool. You can set cycles, you know what I mean, with that. Next, basically every function you have in a real one you've got in the game and you've got in this. The only thing that doesn't work on this panel is the brightness knob. That is because it's the nature of an OLED. You can't use a pot to dim an OLED. You have to do it with software, and it's too difficult. You don't really need it anyway. It's actually a white OLED, but I've got a thin film of like a green cellophane material, which it makes it match everything. You can set your programs for your countermeasure system. You can set everything in it. It's brilliant. That I finally fixed that knob too, so it's nice and a positive click. You can see that the knob is backlit as well. The jettison button is a cutler hammer. You pull that out and it will emergency dump everything. I won't do it now because it'll make everything smoky. So the caution box is pretty boring, but you'll see when I push the lights test button, it all works up. So each indicator has two LEDs in it. They're just 3mm LEDs, and it's really not that hard with the Fidget's 64 board. Basically, each pair of LEDs has two wires that goes to the board, and then you program it in Helios. That's another reason why I have to use Helios, the program, to run my cockpit, the main instrument panel gauges, because Fidgets runs with Helios. I couldn't get it to work any other way. Those panels are pretty easy. They're just switches. You'll see that the CDU, the backlighting came out really well considering it's just LED strip, but CDU works just like the real one. You can change pages. Everything works. The whole keypad works. Yeah, I'm not doing a tutorial. I'm just pushing buttons and showing you how it works. Clear everything. Go to the nav, divert. Yeah, divert to Nellis. Gives you all the info you want. Since we're on this page, we might as well take a look at the ILS and the TACAN. Just say I was going to go to Nellis, so I want to put my ILS on 109.10. So these are rotary encoders on this one. So you'll notice that the design's a bit different in that it doesn't have, because I'm using rotary encoders, it's not a dual stage one. So to turn it on, I just push that down, and I know when it's lit up white that the ILS is turned on. That's run by the Arduino, and the volume knob is a rotary encoder on that one as well. The TACAN obviously strays from the design of the real one a little bit. I'm using a 7-segment display in there that's partially hidden by the panel itself. So when you want to change, you can change the numbers, and then you can change the numbers on that one. But then when you want to switch between X and Y band, you just push that down and it toggles. I've just messed up the programming a little bit. It's supposed to just be, it's actually putting out a 0, but it looks like it's underlining the X, and when you do that, it's supposed to underline the Y. But I've just messed up something there. I'll fix that. It won't take too long. Just have to reprogram that Arduino. And the volume on that one's rotary encoder, and you can see when you turn it on, it'll start beeping. Test button works too, and the test light will light up when I'm on a channel that's actually worth testing. What else is on this panel? The gauges are run by a servo. Even the oxy indicator test button works. So the reason it does that is because in the real, and you'll see that's actually pushing oxy low too. The reason it does that is because this servo's geared and only has 180 degrees of travel, but it knows its position. So when you push it, the sim will tell it you're supposed to be back over there, so it'll have to go back the other way. But it still does the job. There's the oxy test again. The cabin altitude pressure gauge works. When you get to 30,000 feet, that needle will move up to 30,000 feet. It's pretty cool. The rest of this stuff is pretty easy. The main wow factor one on this panel is these three, the CDU. The caution box is brilliant. Righto, so anyway, if you have any questions, please feel free to put them in the comments and I'll try to answer them as best I can.